toughest question. Who is this man who is asking this 9 question from me? This is really good question number 9. Bandar is intelligent boy. Give me 1 minute, okay? I'm sharing the application screen. Can you see this now? Hello? So you want 9 number, right? Give me 1 minute. Bandar, how to disappear this pen? Bandar, which color you like? Bandar, which color? Blue. Okay. So we are starting with the blue color, and our question is 9 numbers. This is what fxyz equal to 3x ln x square yz plus x to the power y upon z. Right? We need find all first order derivatives. What we need? All first order derivative. So all first order means we need fx, we need fy, and we need fz. What we need? fx, fy, fz, right? The screen is visible to you, guys? Okay, good. Now fx means del f upon del x. Fx means what? Derivative of f with respect to x. So this is del upon del x 3x ln x square y z plus x to the power y upon z. Is that okay? Equation number 2. Okay, good. So we can write it as you have 2-3 options here at this moment. This is fine. I have not done anything, just individually the derivative of sum of function equal to derivative sum of their derivatives. Just this property I applied. All right, mister. All right. All right. And where is Basil? Basil. Mr. Basil. Good. Basil, can you see here? This is the product of two functions. One is 3x and other is ln x y square. Right? One is this and one is this. First, second. So what is the rule of the derivatives? Product of functions, derivative of product of two functions. This is first into derivative of ln x square yz plus ln x square yz del upon del x of 3x. Right? Wahil istakat tani plus अव्वल इस्तकात तानी मुजब तानी मुस्तकात अव्वल इस्तकात अव्वल. Right? So this is, and here what is the situation? This is what? Derivative of x to the power n is how much? We are differentiating with respect to which? Derivative of, with respect to x. We are differentiating with respect to x. So this y to the power z is like a constant. Y upon z is a constant. The power is like a constant. So its derivative is y upon z कोइस or माफी कोइस. Hello Allah. Good. मुश्किला? No problem. Okay, good. Thank you. Now see 3x. Here this is ln. What is this function? ln. So derivative of ln is how much? 1 upon x square yz into derivative of x square yz plus ln x square yz into derivative of 3x is how much? This is 3 plus y upon z x to the power y upon z minus. Is that clear? Is that fine? Good, very good. So this is 3x into 1 upon x square yz into 2xyz plus 3 ln x square yz plus y upon z x to the power y upon z minus 1. So you can see this is how much? Then what happened? yz row. Okay, this row, and this is how much? X. So this makes this power 1 cut. So this will be 6x upon, and this is also x. So both the powers gone. So this is how much? 2 into 3 6 plus 3 ln x square yz plus y upon z x to the power y upon z minus 1. Understand? Understand or not? We form? Good, great. What we have done so far, we just find fx. What we find? Now we need to find fy and fz. We need to find fy and fz, derivative with respect to y and derivative with respect to z. We need to find. So let's go for another slide. 3x 7x. Oh, sorry. Bandar? Bandar? Is it fine? Now what do you want? What is your f? This is 3x ln x square yz plus x to the power y upon z. Now partially differentiating with respect to y. في كويس يعني we need fy, or we can say we need del f upon del y. So let's choose the blue color. So del f upon del y equal to 3x del upon del y ln x x square yz plus del upon del y x to the power y upon z. Mister, this is fine. Okay, good. Where is Basil? Basil? Mr. Basil? Mr. Basil? Basil, I think gone. Basil? You are thinking, doctor, why he called my name every time? So you are feeling irritating. I know. Are you feeling irritating, Basil? You cannot leave. I will keep in touch for 2 hours. Next 2 hours. I will call you every time. Don't be irritated, okay? Yeah, Basil is the best. I know he's the best of the best. He's the excellent man. See, what do you want? Differentiating with respect to y. When we differentiate with respect to y, so this is the function 3x 1 upon x square y z derivative of x square y z. Is that okay? I'm taking a snapshot, Basil, and I will give this snapshot to your all teachers who are teaching. That Basil is telling about this to me. Basil, see this formula. D upon dx of a to the power x. Do you know this is how much? This is a to the power x ln a. Basil, you can see here one thing, that this is like a constant because we are differentiating with respect to y. We are differentiating with respect to y. So x and z are constants. This is the main point of this question. Otherwise, this question finish. Only this is the main point in this question. Okay. So I told you this formula for it, or I can show you some trick, means the actual thing. So I will tell you in the detail. So be with me for 2 minutes. So in 2 minutes, you will see how to handle such situation when your variable is in the power, because you are differentiating with respect to y, and y is in the power. So this is a quite some different situation. So let this is phi equal to x to the power y upon z. Okay, this is your phi. You know, if this y is not in power, then we can handle it easily, right or wrong? This y is creating the problem because this is in the power. So take ln. So when we take ln, so this power y upon z will not be a power. Now this is a y upon z ln x. Bandar, focus 1 minute. Now you can see the power of y is finished. Y is now general. Okay. Now differentiating. So derivative of is it fine? Derivative of ln phi is how much? 1 upon phi del phi upon del x. First we will differentiate the outer function. So derivative of ln is 1 upon whatever be the inside, we write that 1 upon, and then inner function is here. How much? What is the inner function? Phi. So its derivative is how much? Del phi upon del x. Oh, sorry. You know, you are differentiating with respect to y, so this all these things is like a constant. This is like a constant because we are differentiating with respect to y. So we can say 1 upon z ln x del upon del y of y. Derivative of y is how much? Derivative of y with respect to y, that is 1, and this is 1 upon phi del phi upon del x. So del phi upon del x equal to phi into 1 upon z ln x. And what is the actual value of phi? So we can write this as 3x into 1 upon x square yz and x square z plus phi. Phi means x to the power y upon z into 1 upon z ln x. This is the derivative of this. Okay. So this is x square cancel, z cancel. So your answer is 3x upon y plus x to the power y upon z 1 upon z ln x. Finish. This is what del f upon del y. Okay. Understand or not, Ali? Okay. Similarly, you know, when we differentiate for z, the similar thing we can get. You want to see with respect to z? Okay, no problem. Okay, I will give you some, this time some better thing. 3x. What is your fx? 3x ln x is x square yz plus x to the power y upon z. Right? Now you need del f upon del z. So this is equal to 3x del upon del z ln x x square yz. So I am giving you one more way this time, okay? You can write this del upon del z e to the power ln x to the power y upon z. Is that fine? The same question in different style. 1 upon x square yz into x square y plus this will be, you know, del upon del z e to the power y upon z ln x. So we can say x square y cancel. So this is 3x upon z and this is e to the power y upon z ln x into del upon del z of y upon z ln x. So we can say 3x upon z e to the power y upon z ln x into y ln x del upon del z z to the power minus 1. So we can say 3x upon z plus e to the power y upon z ln x is how much? This is x to the power y upon z into y ln x into minus 1 upon z square. This is your del f upon del z, okay? Understand or not? Yes, very good. And Abdul Aziz? Abdul Aziz. So you like this one or the previous one? You can choose any method, this way or that way. Very yes. Okay, good. Okay, good, great. Whatever you like, you can choose this. Any one of. It's not an issue. So here is the again the sheet of questions. Do you wish to continue with any question or shall we finish it here? Do you have any question from here? My dear boys, do you have any question? 10 is nothing. Anta if got 10? Maafi muskila. Who is asking? This is Ali. Okay. 10. Bandar? Mr. Bandar? Why is the class strength is low today? This is your question, Ali. Ali, Mr. Ali. So where do you find the difficulty? You just, solved. When you see this question, you are surprised and you are feeling this is tough. But this is the easiest question here. Look. Basil, my dear Basil, this is okay, Mr. Basil. Just we take up the denominator, we take up. So the power is positive. So when it goes up, it will be negative, right? So del f upon del x. So this is 2. How many functions of x are here? How many functions of x are here? Yes, please tell. What are you telling? 3? Only 2. Look. Sorry. This power is how much? This power is how much? 2 minus 1 by 2. And here is the product of two functions. So what is the rule? This is okay? Where is Abdul Aziz? Abdullah, welcome. I see you first time. Welcome, Mr. Abdullah. Oh, sorry, this is Abdul Malik. Abdul Malik, welcome. This is 2, so this is 2 cancel. Minus x square plus y square plus z square whole power minus 3 by 2. And its derivative is 2x. Minus x square into derivative of exponential function is same. Then derivative of is it fine? So we can write it as minus 2x upon minus and its derivative is y upon z, and we can write it as okay, no problem. This is fine. Understand? This is del f upon del x. Similarly, you can find del f upon del y and del f upon del z. Would you like to try something? Can you try for del f upon del y and del f upon del z? The similar, very easy. Del f upon del y and others are easy because in this part, here this is the product of two functions when you go for x. But when you go for y, only this is the function of y. This is a constant when you differentiate with respect to y. Okay, you want to see that or you can do that? Hello? Let's see it. Okay. Now we want to find del f upon del y. So you can write it as 2 cancel, and here this is 2y. So this is y whole power minus 3. 2y upon x square plus y square plus z square whole power 3 by 2 minus x square e to the power xy upon z into x upon z. Finish. Over. Similarly, you can find del f upon del z. This will be minus 2z upon x square plus y square plus z square whole power 3 by 2 minus x square e to the power xy upon z into minus xy upon z square. This is del f upon del z. Okay. Okay, fine. Any other question? Hello. This is 1 minute. Del C upon del T. Can you do 27? 27. 27. Is any problem in 27? Hello? 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 Abdullah? Abdul Malik? 27 is any problem? Estimate the partial derivatives del C upon del T at tangent and del C upon del X at tangent. 10. Temperature 10. Question number 27. These are the wind speed and temperature are recorded. So you need to find del C upon del T and del C upon del X. How you will find it? 27. 27. Bandar, can you do it? See, Bandar. Okay, you will try and get 2 marks if you do it correctly. Are you trying? Yes. 1.3? Nope. How you are getting 1 point? Which formula are you using? Del C upon del T is equal to uh, equal to C C T plus H minus C T S upon H. This is the formula. and del C upon del S is equal to C T S plus H minus C T S upon H. This is the formula. You need at 10, At what point you need? 10. So this is equal to CT 10 plus H comma 10 minus C 10 upon H. H is how much? This is the difference. H, the width. This is how much? 10. So CT plus H 10. 10 means S value is constant. So S is 10 where? In this value is 10. Right? Hello? So this is how much? How much is this? CT plus H. How much is this? Means 10 plus this is here. This is how much? CT plus H is how much? Tell me CT plus H is how much? You are shocked. 1.3 is your answer. I think this is correct. See here. I am going to the table. Table is here. 1 minute. How much is this? C10 is how much? This is your C10, right? So this is minus 10, minus 9 upon 10. And this value C10 plus H and 10. Hello? Hello? C10 plus H is how much? How much is this? Bandar? Bandar? C10 plus H. H is how much? You can see every time you are getting this value minus 10, 10 minus 20, minus 10. This is how much? Minus 10. This is how much? Minus 10. So if you are here, then H value you are getting how much? Minus 10? Yes or no? And CT means this is how much? Minus 24. So this is minus 24 plus 9 upon 10 upon minus 10. Minus 24 plus 9 is how much? Minus 24 plus 9. Minus 15 upon minus 10. So this is how much? 1.5. Okay? Okay or not okay? Because when you put h equal to c here, when you put h equal to minus 10, so how much you will get? C 0 10 minus C 10 10 upon minus 10. C 0 10 is this point. This is your C 0 10. And C 10 10 this point. So C 0 10 minus 24 plus 9 upon minus 10. So this is how much? Minus 50. Is that clear? Similarly, we can find del C upon del S. Can you find del C upon del S at 10 10? You can see here this value is increasing every time 5 increasing. So here you will get del C upon del 10, del C upon del S at 10 10 equivalent to C 10 15 minus C 10 10 upon 5. And C 10 15 is C 10 15. C 10 15. 10 and 15 is minus 18. So minus 18 and minus 9 upon 5. So this is minus 18 plus 5 plus 9. This is minus 9 upon 5. Minus 9 upon 5 is how much? This is the change in S and change in T. Okay? Minus 1.8. Okay. Minus 1.8. I think you understand this point. Your answer is same? Oh, 2 marks awarded to Bandar. Is any problem? Hello. Now we will see the change of variable. Can you see this screen? The linear approximation. So please note down this formula quickly. Noted? Abdul Aziz? Abdul Aziz? He is not here. Today you have any exam? Done. I'm not going in detail. Okay, good. This is the linear approximation. So I would like to go with the linear approximation, but I don't find time. This is the find total derivative. Okay. One more thing you should note. Find the total derivative. See this. Actually, it takes time, 1 or 2 minutes to switch the application window. Can you see this? Find the total derivative. I'm writing here total derivative. If f is a function of xy, then total derivative of f is written as df. df is what? This is the total derivative, okay? And defined as we define in such a way. If f depend on 3 variable, then how we will define df? If f depend on n variables, then when we define df like this. Noted? Is that fine? Now see what is the question, y e to the power x plus sin x. fx is how much? Y e to the power x plus sin x. This is your function. We need to find the total derivative. So df equal to, all right. So what we need to find here? We need to find del f upon del x and del f upon, and after getting them plug in here. Okay, the point is clear. So del f upon del x equal to del upon del x y e to the power x plus del upon del x sin x. So with respect to x, this is a constant y, so we can write it as, and derivative of this is y e to the power x plus cosine x. This is your fx. And similarly fy e to the power x. This is your fy. So df equal to y e to the power x plus cosine x dx plus e to the power x dy. Okay, all right, mister. Can you try another question? Hello? 33. 33. ln x y z minus tan inverse x minus y minus z. fx y z equal to ln x y z minus tan inverse. We need total derivatives. So df equal to fx dx fy dy fz. So we need to find fx, fy and fz. We need to find these values. Can you find it? Done? Hello? Hello? Hello?